Okay, so today we are going to speak about scoping. But before we start, because there has been lots of questions about teams, projects, ideas. Let's have a brief chat. Today you were supposed to figure out your teams, right? Is there anyone here that was not able to find a team, or is there any team that it's not like there are only 3 or 4 students? They need more students. Can you raise your hand if you don't have a team or you need team members? All right, 1, 2, 3. 3 back there. All right. So there are 3 students back there. There are 3 students here. There are 4. There are 4 here. There are 3 students here. I think you guys can talk. Maybe there's 1 student here. So that's what I'm saying. That raise your hand if you don't have a team, or your team is not complete. Okay, you have 3. 1 student here. There are 3 here. 1 here. Anyone there? All right. So I feel like there's about 80 students here. I would recommend you to put each other between the class or after the class. If there is any common ground or for the idea that you want to work on, then maybe that could work for you. The other thing is that I received really interesting question that could we use AI for our product, building a product, like a vibe coding idea. And my default answer is that the reality is that, if I say yes or no, you will use it. Right? But also the reality of the market is that everyone expects you to know how to use the tools, right? And I think you can definitely use this type of thing. But at the end of the day, remember, this class is MLOps, not the ML. That means you can use vibe coding to build your model, build your whatever like a application you are building, but the ops part is not something, at least with the current AI tool in the market, I don't think you can do the ops. You basically need to do the ops yourself. So I don't mind if you use again AI. Just remember, whatever you build, at the end of the day, your demo day is you are selling that idea. And me or the judges will ask the question about, okay, tell me about this part. You need to know that part. Even if you haven't built it yourself, you need to be able to talk about the product that you're demoing. Okay? So you cannot come over there and say that, well, I use AI for this one. Even if you use the AI to build that section, you need to learn it yourself. How does it work? And why should I be convinced to buy from it? Even if you built it by AI. So that's another thing. The third topic is that about data and idea in general. I think it's more important for you now to find out team members that you're kind of like aligned in the domain that you want to work on, rather than what to work on. Okay, that's going to take time. That's why after today's deadline, you have about 10 days to figure out what you want to work on. Okay, so the idea is that we first figure out the team, and then sit and together find one of these rooms and in library, one of these whiteboards. Everyone basically comes over there, and one funny thing you can say is that put a hat and says that no stupid ideas, right? Any ideas is acceptable. So let your innovative basic persona come up with ideas right on the board, and then talk with your team members about, okay, which one make more sense? Is it feasible? Can we do it? Where could we get the data from? Because it shouldn't be just an idea that sounds cool, or that an idea that you feel like, okay, it's going to be perfect. You need to think about feasibilities, right? Is this feasible? Is something overall doable, like from engineering perspective? is this something that's like a viable? That means from business perspective, if I build this product, will anyone want it? It could be great engineering tool, but the crappiest business basically product, right? So you need to also be sure that you are not only engineering in this class, you actually need to put your business hat. Whatever I'm building is a product. I need to basically assume someone wants it, right? So who's the person who wants it? So you need to think like that, not just engineering. And the third part is going to be around the design. So just be sure that you have a proper design by also. That means it also look good. Okay, so three things. Is this something that I can build a product with a good design around it? Is it engineeringly feasible? Third, from business perspective, is it viable? If you could find something like that, then you can basically work towards it. But if you find an idea that's engineering feasible, but is not a good business model, is not a good, I don't know, like you cannot build any like a nice product around it, like from the dashboard perspective, then maybe don't work on it, right? But if you have all those three, or into a so-so also, then probably you can work on that idea. All right. Again, remember, scoping is iterative. You can change your scoping as you go through it. We're going to talk about the scoping today. That means if after 10 days after your submission, you decided, okay, we are not going to work on this, we are going to change it. You are allowed to do that. But sooner you figure that out is better for yourself. Okay. All right. So we're going to talk about the scoping today. So let's just start with one thing. It's a quiz. So give me an answer. What do you think? What percentage of AI ML projects typically fail to reach the production or deliver a measurable business value? 1, 2, 3, 4. 3, 4. Who says 4? All right. So it's a combo. Technically, it's a 3, but the recent basically study by Bain and also the other one, the basically say that 95% of the AI initiative failed last year. Okay, that's for the AI initiative. But from data science products or like projects, between 70 to 90% never ever leave that laptop. Doesn't matter which company you work on. You build something, you think it's cool, they think it's cool, but then later when you deliver it as a product to the rest of the company or the team, the business team, they don't find it valuable. Right? So what does that tell you? Why we work on something that, it's kind of like we thought it's good, but it's not good. We waste all that money and all that effort. Some companies have a different answer to that. There are lots of research companies that they just want to patent ideas. So they work a lot on ideas that they know they are not going to convert it to a product, but they will patent it, so they have the right. Lots of companies are like, they can do something like Philips, Mitsubishi, stuff like that. They do. They're constantly patenting things that never build the product. Actually. But there are also some companies that they want to build something, and they think it's cool, but they kind of rush to. And at the end of the day, you build something, your team works on something for 6 months to a year, and then that's it. And to be honest, that's one of the worst feelings. When you work on something and you think you built something cool, and 6 months later, everyone asks you, so what happened? What were you building? Where's that product? You're like, it's gone. I'm working on something new, right? Because the good feeling is that you build something and it's out there, people are using it. But unfortunately, 70 to 90% of the time, wherever you go working, that's not going to happen. Right? So we're going to connect that to an idea of scoping. And the idea for scoping basically here is that how to decide what to work on that is not just like a need, but it's actually it's a valuable like a business model. It's actually something that will help us, from the product perspective. It brings value. It helps our customer, and it's actually basically beneficial. It's kind of from all sort of perspective, we're going to talk about this. So let's just start with this. What is scoping? So we're going to start with one example. Let's say you have a company, you're like a consultant agency, and people come to you and ask you for, to work on a project for them, or help them with part of the product. And so let's say for this example, e-commerce comes to you and say that they want to increase their sale. And they come to you and say that, okay, you know what? We want to use AI and or ML, and we want to increase our sale, right? So the first thing you as a consultant is that to understand what's the problem, but also it's first to, from your perspective, because you don't want to work on something that doesn't have the chance to win, so you need to also figure out, is this something that they want to work on or not? So let's say you decided that I want to work on this project. Then the next question is that, okay, what are the metrics for success? What does it mean to be a successful, like a retailer, like product? What does it mean? What does success mean for the customer? I can build an app for you and build an ML model, but what's that moment of aha that the customer will say, well, that's great, I like it, it worked, what are the resources that you need for this, like the data, time, people? But then the other thing is that, what does it mean I want to increase the sale? Because from our perspective, we are engineers, right? Someone tells you to build an app to increase the sale, like it doesn't make sense. Why? Because anything that you build in ML domain, you have some objective function that you optimize for. Objective function is never revenue, is ML metrics basically. Right? So if someone tells you to build something that increase the sale, it kind of like you're like, well, I don't know what does that mean. So you need to ask follow-up questions. Does increase in sale mean to have a better recommender system? Does it mean to have a better search? Does it mean to improve the catalog that we have, or inventory management or price itemization? So optimization. So all of this basically means follow-up question that you need to ask. But the most important part for you is always to, whenever you try to solve a problem, and this is also for the product that you're going to build, first try to find a business problem, not an AI problem. Okay, so you need to think with yourself, what is the business problem that I'm trying to solve? Then you brainstorm an AI or ML solution for that problem. Why? Because if you focus on using an AI problem to solve something, you only will build a project. But if you focus on business problem, you will build a product. That is the difference. So focus on first finding out what is the business problem. Then, what's the AI solution that you can use for it? Then you go to the next question. Is it feasible? What's the value it basically adding? What are the milestones that we could do? Like, for example, you talk with the customer. Okay, every 1 month we're going to do a delivery, or every 2 weeks, depending on what's the expectation, what's the timeline. And we're going to break it down in this format. So whenever you work with consultant, they basically give you these milestones. That, okay, you know what? First 2 weeks we're going to do this. Second 2 weeks we're going to provide you this, and so on and so on. So ahead of time, you basically have they do their own scoping. They bring their scoping with the pricing, and they provide it to the company. And the company basically reviews that. You negotiate, or you change the timeline based on your expectation, back and forth. And then all of you basically agree on one total scoping document. Right? So, and then the last piece is the budgeting for the resource, like how much basically is going to cost. And that budgeting doesn't mean just what's the cost of cloud services you're using, is the cost of, okay, we need 2 engineers, 2 Python engineers, we need 1 data scientist, we need 1 data engineers, and so on. And you're going to basically cost all of those based on like hourly rate that they have. And you basically tell that, okay, it's going to cost us this much. So now it's really important for you to be able to separate the problem from the solution. And you can basically do that by asking a series of questions. So the problem basically is that increasing conversion. You want to increase conversion. That's not the solution. That's the problem. Your customer asks you that I want to basically sell more, increase my revenue. One of the ways that you can do that as a problem is that improving the conversion, right? How can you do that? Well, I can improve the search. I can improve the recommendation. So you need to basically ask this question: what to achieve, how to achieve it. What to achieve is not going to be your AI basically answer. How to achieve is going to be that AI solution that you're going to have. Like it could be, I want to reduce the inventory. Well, how could you reduce the inventory? You need to improve your demand prediction algorithm that basically tells you that how many order from each item. Or you can improve your marketing so you can basically kind of sell more. That way you reduce the inventory. I want to increase the margin. Well, you need to optimize what to sell. Maybe do some sort of like a bundling, you know. So those all becomes what to achieve versus how to achieve. Now, the next part of the scoping is the diligence on the feasibility and the balance. Now, feasibility means that asking this question that is it actually doable, right? Because lots of time, again, you will hear ideas like, we want to use machine learning, we want to use AI for this. Is it actually doable? Or is it actually necessary, right? When we work with AI or machine learning, you always have two types of basically problem. It's either a structured data problem or unstructured data problem. It's one of these two. So we can basically break it down into two, basically unstructured versus structured, new versus existing, new project versus existing project. Now, let's just start with the structure. Structure means that anytime the data that you have is tabular, right? So some sort of like the database type of data or like a data frames, right? So anytime you deal with the tabular data, you need to ask this question first. Is this a new project that you want to build? That means you never had something similar to that. This is the first time you're using this. If that's the case, the question that you ask, is there a reason that you believe this data can map to that answer? Is there any like a correlation, for example, among the features and that target? Because someone could come and say that I have a data, I want to do this with it. The simplest thing you can do is that give me a stat, I can tell you if that data is useful. If it's an existing project, that means something that they already have that product, you know, but they want you to improve it. Then the first question is that, is there a reason that you believe that this can be improved with this data? Do you have a new data that you didn't have previously? What has changed, right? So basically you look at is there some sort of new predictive signal in the data? But also you look at the history, the previous product that you had. What was the success rate then? You know, that's a way for you to see that if it's feasible or not. When it comes to unstructured, that means audio, text, image, videos, right? Those types of data is going to be a little different. If you work on something that's new, the company, like in the company, you haven't worked, don't have that product. The first question that you need to ask, it's called human level performance, HLP. That means, is this task doable by a human? If I give this to a human with the domain knowledge, can they do it? If not, why do you believe AI can do it? All right, so that's HLP, human level performance. For unstructured data, we always use HLP as the first way to validate if this idea is doable. And we're going to talk about why not for structure. If it's an existing product, an idea, then you ask the same question. First, let me look at the HLP, then look at the history project, then look at the new data to see what has changed. Why do you believe it's basically going to improve? Now, can anyone tell us why do you think we use HLP, human level performance, it means human judgment, on unstructured task, but we don't use it in the structure? Yes. Let's assume the data is clean.
First thing is you need labels for the unstructured.
Let's assume you have labels, data, clean, everything. Why we use human on unstructured data, but not for structured?
Unstructured data may be difficult to interpret by like a running model or something, but a structured data can find in common values that can easily be used.
Not the opposite. Yeah.
It's a bit subjective when it comes to unstructured data. Like, so you can identify a car, you can also
identify a person, but when it's unstructured data, it's usually fixed, right?
So let me ask you a question. If I give you a table and I tell you that, what patterns do you see in it? I give you a table and says that does this person, by looking at this table, do you think this person has a cancer or not? Versus if I give you an image and it says that do you see a cat in it? Which one human does the best? We are the best when it comes to unstructured tasks. From the time that you're a kid, your brain automatically learns how to work with unstructured data. Audio, as a kid, you can hear your parents' voice among the crowd and detect it, right? But if you are the best mathematician also, you can look at the tables after a certain number of columns, you're lost. You don't know what's going on. So humans, we are not good at any structured data types because it's difficult. Seriously, if you look at any table that you have on your computer, how many columns at the same time you can focus before you need to go, okay, I lost it, let me go back. But an image, you can look at the image and you can quickly memorize everything that you see in it, even in details. So when it comes to unstructured data, we always use human because if a human can do it, then we say AI also can learn it. But if a human cannot do the task, that doesn't mean the AI cannot do it, but it's going to be much more difficult for AI. Probably you need much larger model, much better data set, much more training in order to teach AI to do something like that. An example here is that when you look at the light on the left, what color do you see? Green. So you can detect the green. And definitely you can teach that to an AI also. That's a green light. What color do you see here? It could be any of those three. Technically, it's actually all three at the same time. So what does that mean? If you're dealing with an image that has a bad quality, the data that you have, you took from, it has bad quality because of lighting, the way that sun was projecting on it. And a human cannot detect what it is. Why do you expect a self-driving car be able to do that? All right. So that's basically becomes the important part, human level performance on unsupervised tasks. Any question on that so far? All right. Now, let's look at the structured data. Given past purchases predict the future purchases. Definitely we can guess that. Or given weather predict the shopping mall foot traffic, given DNA input predict the heart disease. These types of questions, structured data, you can't ask a human to do that. But you can, as a human, watch a movie or watch a video and predict what's going to happen in the next scene. You can even visualize how things going to move in the next scene, like where the person will be standing in the next scene. All right, you can basically have that basic imagination. Now, when it comes to history of a project, which is pretty important, because if you're working on a project that it has been already in a production, but they want you to improve it, you need to be sure one thing, do not overpromise. Okay, that's really important. Do not overpromise that we're going to get 99% in 2 months. Everyone wants to hear that. If you promise something that doesn't work, just it's bad for your reputation. So what you want to do is that always be sure that whatever you promise as of like improvement, it's something that makes sense, but it's also something that's iterative. It's not going to happen overnight. If a company has a product that they had 10% error before they bring you on, what's the reason you believe you can just drop it to 1% in it overnight, right? So instead of promising like that, you basically define quarterly. Like maybe you say, in Q1, we're going to basically start working on, at Q2, we will have 2% drop, for example. Q3, we will have 2% drop, and so on. So that way, you don't overpromise something that's you don't know actually is it feasible or not. Right? There's no way that you ever reach to that basically end also. It's kind of like the data changes, model changes, and then the performance might even get worse over time. Now, when it comes to diligence on value, one of the things that's really difficult in reality is that if you work in anyone has here worked in the startup before, right? So startups have you sat in the product managers and then business team at the same time, right? So they always challenges. What's the challenge? Is that you don't understand each other's language when it comes to product. What they want, what's the product team wants most of the time is we want business metrics to go up. That means the revenue. That's what they see. What you understand is the machine learning metrics. I can answer with respect to that. They tell you that how good is the model? We have 99% accuracy, right? You never can answer with respect to revenue, but they don't understand what you say here. So what do you need to do? You need to work with the product team, or basically with as some sort of a cross-functional team, and find a proxy in between. That means, okay, you are building some sort of like a, let's say, basically query system, chat basically respond. And you're solving word level accuracy. You're like, okay, I can convert that word level accuracy into query level accuracy. That still works for me because I can basically average this. Then I can go one level further, search result accuracy. If we have a good search result, then at this point, you don't need to go further. You can basically, the business team can come to you, they meet you in between. If we have a good search basically result, that means we have a higher user engagement. Higher user engagement means that we're going to have more revenue. So you want to understand, if you want to sit in these types of meetings and talk with the product team, you need to find how to talk also in their language. So what makes sense for you, that doesn't mean that makes sense for everyone else, especially as an engineer, basically software engineers, lots of things that you have in mind doesn't make sense in those types of meetings, right? So you just try to find a proxy or a level in between that you can convert your model performance. That means if you're working on a model that you're training it on word level accuracy, do some sort of aggregation and maybe report the search result accuracy to a higher level people in the company. But for internally, for the engineering team, you just focus on the word level accuracy. So now the other thing is that the ethical consideration, which is pretty important, especially as these days, the AI use cases are kind of like a changing widely. So you need to be sure that whatever you work is ethically basically responsible. First thing is that ask questions like, is this project creating a net positive social value? Is this project reasonable, fair, and free from biases? Or like, is there any ethical concern that basically you need to basically air or discuss? Be sure to ask these questions. So many times I hear like people like, I'll just work on a project idea. But sometimes you need to basically, you need to have a voice, right? I have done that. Last year I joined a company. 2 weeks later, I left the company, technically kind of got fired from the company because I raised so many concerns over there after 2 weeks. And they built a model they were selling this model to the customer. I'm not doing the name, but selling this model to a customer. Customer was using this model as of like they use it as like a tracking mechanism, time tracking for the employees. And they were giving an activity score to every employee, and the customer was using that score to fire people. And 2 weeks in this company, I'm like, how did we come up with the score? They're like, this is how we came up. I said, where did we get the label? Like the score that you use to predict where we get it? They were like, well, the CTO came up with this scores. I asked the CTO, how did you come up with it? It was like, I use this, I give this much importance to this factor with this. You manually? I was like, yeah. I was like, people get you fired, right? Well, and then one of the answers that I got from that company was, if customer trusts us, why should we care? They trust us to use our product, right? I was like, yeah, it's like this most stupid question, but anyway, sometimes if you have a voice, like me, after 2 weeks, you basically need to leave the company. They were like, actually, the excuse was interesting. It was like, you are not a good basic cultural fit for the company. I was like, I'm sure I'm not, but just be sure it's sometimes you need to do that. Now, milestone and resources. Okay, so this has become really important for you and what you work on. You need to be sure that you define series of milestones and series of basically metrics for your product. And these metrics are going to vary. So you're first going to have ML metrics. ML metrics like accuracies or like, I don't know, like depending on what have you used, okay, classification, regression, text generation, whatever metrics you have over there. But then you also need to have software metrics. Software metrics comes around the pipeline itself, the package itself. Like how long does it take if when a user works with it, what's the latency, what's the CPU footprint, what's the GPU footprint, those types of things become your software. Then you go to business metrics. And business metric, let's say for you, you don't need to have revenue, but you can come up with metrics like user retention. If a user comes on my platform and they use it, will they come back? Will they basically, it's kind of like a sticky product. It will basically stay around, or they're just going to try it one time and then basically that's it. And then you need to talk about the resources that you need, the data, personal, and basically any other thing like you need, like from computer perspective. If you're not sure about timeline, what you can do is that either use knowledge that you have from other projects. Maybe you have worked some other project that was like, okay, last time I worked on something like this, it took me this much to build the UI. It took me this much to build the backend. So you kind of like aggregate that basic answer. Again, also, if you don't know that, ask your TAs, ask me. I will give you an average answer. I think it's going to take you this much time, for example, to work on something like that. You can also, in reality, build POC, proof of concepts. Sometimes you can build something quick to just see that if it's feasible or not. These days, to be honest, I do lots of vibe coding for POC. Like, I have an idea, I want to see if it works. I sit like a weekend, 2 days, and build the smallest version of that using AI. And if I see that if it's feasible, it works, then I will say that, okay, let me compare it with the other ideas, see that if is it worth basically to put the time on. So you can do POC much faster these days. Iteration, that part is much faster. So keep that also in mind. Now, so you can basically, this is like an interesting website. It's called Made with ML. You can build a chart like this for your scoping as an example, but you can come up always with your own template. I have over these years, like I built a template for myself for every project of a product that we want to work on. I use that template always as part of my scope. It's like a fix. And over time, I improve it. And, you also need something like that for yourself. Maybe use this course as a way for yourself to build the template that you can reuse later. Now, so up to this point, we just talked about general, basically scoping. But when it comes to LLMs, most of you, I know that you're using LLMs, the scoping is going to be a little different. Because the classical ML scoping is just, there are lots of consideration around feasibilities from perspective of can we do it? Do we have a data for it? What's the cost? What's the engineering that we need? But when it comes to LLM, there's more questions that basically you need to answer in order to do that. The first thing is that you all have to use tools like that, but there's after this, ChatGPT, every company basically started like, we want to use LLM in our product. But there are a series of things that they were unsure. The first question was that, how much is going to cost us build it, right? And that's actually still a question companies will ask you that. When you have an idea like and it's LLM related, the question is that they know they want to do, that everyone's kind of wants to do it, but they're like, okay, how much is going to cost us? This is going to be like a 5,000, 50,000, 500,000, or so on. Like, what's the actual cost? And unfortunately, when it comes to LLM, it's not that straightforward to come up with that numbers, because there are so many variational costs and fees that you basically accrue to you on during the building the product that they might basically surpass your expectation. The other thing is that, well, how long does it take? Right? It's like something that you can build it in 3 months, 6 months, 1 year. And that's also itself is going to be a bit challenging. So we're going to walk through 5 steps that you can use for your LLM projects. The first one is that you need to basically, in order to define a use case, always start with something that's small, but it's also valuable. Lots of time companies these days they use AI for some sort of like efficiency improvement. At least LLMs basically mostly being used for efficiency improvement, to speed up a process, to reduce the manpower you need for something, or to basically improve the efficiency on certain pipelines. So you need to first remember to start small. Don't aim for something that's going to be really difficult and big, and solve something that's real. Focus on 2 or maybe 1 or 2 specific use case. Always try to find something that's repetitive and basically time consuming, and you can help with that. That's normally something that AI could use. Any time that you work in a company that you have lots of domain specific jargons that is not easy to work with, then you might basically be able to use AI, especially LLMs, for those type of things. If whenever the outcome basically directly impact the business metrics, you can basically use AI for this. So you need to first figure out because why you need to figure that out. Sometimes you go to a company and they want to use AI and they ask you to, we want to use AI. They don't know where. So you're responsible for coming up with the ideas, right? Instead of randomly throwing ideas, pick something from this tree and say that, okay, which one of this we can work on, offer the ideas and with the benefits that they have, like how much it's going to cost, how long it's going to take, and then you will basically decide on which one you want to work on. Be sure to simplify your goal and use some sort of like a successing or your stepping steps. Kind of like you also need to define those metrics. Now, the next thing is that when it comes to LLM is you need to decide, are we building something new or are we basically streamlining something that already exists? Okay, so if you are building a new capabilities, that means you are going to build something innovative, something that the company doesn't have, but it's going to be really good for the company, right? So that's becomes a new basically capabilities. You could also streamline some existing problem. Like for example, you have engineering team that they are doing a certain task in a certain way, and you notice that it always takes, let's say, 2 weeks in order to prepare certain documents. And you're like, okay, we can use AI maybe to reduce that to 1 hour, something like that. And that easily will sell. We recently worked on some product, it's called Scan AI. And in manufacturing, especially in aerospace, because they have been doing it over years, they're pretty good with that. They are good with building the airplanes. They don't want to change anything about it. So what does that mean? That means engineers on a shopping floor or floor shop, basically, they have these PDFs. Let's say you want to build a drone. They have these PDFs, and they basically look at this PDF, says that, okay, you use this part, you use this tool, we put this picture, and it's all written in a PDF, right? So an engineer comes basically read that, and they have the platform, they go enter all this information. So sometimes when one engineer, when they work on a document, and this document has, let's say, 100 pages, 200 pages, that they need smaller steps. They need to go through it and they enter it. The doing of the process is much faster than entering it in the system, because they need to go through this really precise operation of entering everything in the system as basically kind of like they perform it. So what we built was, we were like, okay, we have that product already that they come on this basically app and they enter the information. Could we digitize it for you? Now, what they do, basically what we built is that the same user comes, they scan the PDF, basically upload the PDF. Instead of they enter it manually, we already convert it into a digitized format, and it's kind of becomes some sort of like, imagine like a HTML that the user, at the same time that they go, they just click and they do the engineering work. So they don't need to, so that process used to take them hours and sometimes days. Is right now it basically happens in like 14 minutes, 1 hour, right? And from the business perspective, if you think about it, you're like, that's such an, engineering perspective, you're like, but that's such an easy idea, right? You just digitize the process conversion. But from business perspective, customers already bought. They're like, I want it because all my engineers complaining about manually doing that process. So you basically pick one idea, something that is already being done, but you're like, we can improve it. We can improve the efficiency. And you basically focus on that. So you decide here which one you want to do. You either build something new or you improve the efficiency of something that you already have. Now, for example, let's say you work on, you have the customer service representative. And most of the time, if you have been on a phone call with customer service representative, what they do, they need to search at the same time, get the information, to just collect all the data related to the topic that you're speaking. One thing you could do, like lots of this basically AI or agentic basically CSR these days, basically at the same time that you call, basically agents or AI has this capability to search through the database, pull all the recent transaction, recent chat, everything, summarize it, make it ready for the agent who's speaking with you. So the agent doesn't need to go through any of that process to do that search. As soon as they're speaking with you, they have the summary of everything happened. And it's kind of like a clickable. They can go back through time and see, if they need something like more detail. Basically, build something like that, which is pretty straightforward. And that will, as an impact, have a happier customer for you, basically your brand advocate, basically maybe reduce your churn. There's no guarantee, but it's possible. Now, the next thing is that, which, not that much is possible in this class, but in reality is that you need to build a cross-functional team. That means you basically need to be sure that you have your team, the team that they know, and it's part of the company's culture. That the team that you're working on is not just 3-4 engineers. It's going to be from different backgrounds. So you have data scientists, data engineers, software engineers. You have product managers, because you don't want to put all the engineers in one room, because it's great, but no great product will come out. Right? You need different minds basically over there. Be sure that the product builders, they have direct access to customer. They can sit with customer, talk with customer, get the feedback. If the talent is lacking in-house, that means if you don't have the necessary 1 engineer or 2 engineer right now, don't waste the time. You're like, we need to get the money to hire. No. Instead of waiting for that time, hire some, basically outsource some, from other companies, anyone consultant for that job. And what the benefit of that for you is that they help you to speed up the process. And meanwhile, you can focus on doing the hiring. So don't wait just because you don't have that knowledge or that one specific engineer. Outsource that for one project, and then meanwhile focus on hiring. Okay. And again, remember, plan ahead. Remember, technical and business teams, they talk differently. So you need to basically figure out a way to map those together. Which brings us here. Remember that engineering and product thinking is not the same thing. Okay. We always think in terms of constraints and algorithms. Product focuses on terms of user experience and the outcomes. What's the final goal? You need to be sure that you have some sort of cross-functional team that define a clear problem. You have a clear problem definition. That means a definition that, from business perspective, they know what it means. From engineering perspective, you know what it means. The details of that definition for the engineers could be later defined by the engineering lead. Like, okay, we know what we want to do. We're going to have another internal scoping meeting, and we're going to break it down how we're going to do it. That how we're going to do it, it doesn't need to be the business basic definitions. And then be sure that you have a realistic scoping and faster iteration cycle. The sooner that you iterate, the sooner you fail, the better basically the chance to improve it. Now, so the next thing you can basically think of is that you need to build something called a DRPD, or Database Product Requirement Document. And we have this term, product required document, PRD, but data product required document is sort of like an ML version of the same thing that has been in basic text before. So what you want to do is that you want to have this document that talks about what you need for this project. There are some core elements that you're going to have in this document. Purpose, that the definition of what you're going to basically work on, what's the goal, definition of success, for example, data source. Where is this data coming from? And some of your students were asking about the data for the product that you're going to work on. That's really important to remember. Whatever idea you have, where are you going to get this data actually, right? A school doesn't have the data, we don't have the data, so you're responsible to find out your own data. Where are you going to get that data from? Is this actually a good data? Is this actually real data? Who owns that data? Can I use it actually, you know? So you either have an internal data, that means the company has been collecting data. External data could be either you crowdsource the data or you buy the data from these companies that they are making synthetic data, basically, right? So that becomes external data. You could basically have hybrid, basically. That means you have some data yourself and some part you don't have, then you basically buy or crowdsource that part. Then you need to define the dependencies, which is from the dependencies means list of people, teams, tools, and basically external blockers. What I recommend you is that for your product, whenever you figure it out what you're trying to do, build a chart for yourself on kind of like it's kind of like an engineering on shift. You know, for example, engineering A, basically team member A, knows this concept. Engineering 2 knows this concept, and so on. You have the list. And then let's say engineering 2 is supposed to work on part B. For some reason, that person is having a hard time, and that person basically there's something, you know, they are not going to be on time. Whoever in the team is responsible for the kind of like a product manager, as a product manager, will look to see who's the next person among the engineers that can help this person right now. And so instead of everyone wait for that one person to go through hell and the product basically be delayed, you automatically change the basically routines and say, okay, you for now, you're working on, let's say engineering A is working on something that you say, okay, pause for now, help the other engineer, you know, you basically reallocate the resources, and then we continue from there. Okay, so be sure that you have some understanding of your team's capabilities and strengths and weaknesses, basically. Come up with the evaluation metrics. Basically, you need to know that ahead of time what you're going to use. One of the really common questions that we have, especially last 2 semesters, lots of students using LLM, is I don't know what to evaluate. I'm using LLM, I'm using an API call. I don't know what to evaluate. I don't know like how to account for bias and fairness if I'm not training a model myself. I'm using an API basically. That is correct. If you are using LLM and APIs, that's correct. Maybe you cannot directly answer those questions with respect to that LLM, which for some of those you can, but you need to answer that question with respect to your final product. Whatever product you build, you can still look at that product as a whole, please, with respect to some evaluation metric, or even for bias and fairness, not just the LLM being used in it, in general, that product. If I give this product to 2 category, 1 female or 1 male, and I look at the final output of this, my product, from time perspective, how long does it take to generate answers like a like or dislike, is this going to be equivalent? Is this the same across both basically studies? Right. So you can look at basically those metrics also. Feedback and monitoring frameworks, and we're going to talk about this later, but you need to basically account from now for monitoring drifts, for monitoring basically decays in your model or data, and also in general for any basic interaction that user has. So log as much as possible. Okay, so just log, and then later you can trim those logs. Now, the next thing is that, well, choose the right LLM for your what you are building. The other question is that, okay, should I use an API? Should I fine tune basically my own LLM? That's always your choice, but you need to remember if you use an API, there are lots of strong models out there that, they're pretty good, but the challenge over there is that they are expensive, especially if whatever you are building going to be used by so many customers that sometimes the cost is going to be too much for the company, right? You need to account for that, all those licensing and stuff like that. The other problem that you have with the closed source models is that the data security. That's another thing to keep in mind. The other thing is that you will have always vendor dependency. That means whenever that vendor decides to change that model, you don't have anything. That model is changed. That happened like a couple of months ago, right? Google changed all the Gemini models at once. So they used to provide different Gemini levels, but they didn't update in all of those, and lots of companies result went down. Why? Because you prompt specifically for the previous behavior of the model to do certain things, and now the model has changed. So if you have vendor dependency, if something changes, you don't have the control over it. Okay. But if you do open source, that means you go on Hugging Face or basically find one of these open source models and you download it, fine tune it, or you even without fine tuning, you can download and deploy it yourself. I mean, let's say you pick a model that can load on one GPU and you just bring that and just deploy that yourself, right? The benefit of that is you don't have any dependency, vendor dependency. The only cost you will go through is the cost of infrastructure that you're using, that GPU that you're basically hosting on, and the engineering that goes around building that first stuff. But then you always have the control over model version, and you also have control over the IPVs because it was open source and you built something for that. So that's really important to also figure out. Also, depending on the company, you can use one versus, or sometimes you can use both, but it's always varies. Okay. Yes.
What would be the drawback of the one?
I think it depends. What do you mean by drawback? Just like why someone not want to use it? That's it.
By implementing an open source model during the project, what challenges do we normally trade-offs for which we might have to go back to those?
So challenges. Okay, so that's different. So challenges are a lot. The first thing is that they are not that easy for deployment. It might sound so. We will have lab on. There's a platform called Modal that I use for any fast iteration research. Anytime I want to quickly deploy one of the Hugging Face models, Modal, for example, it provides GPU that you can just quickly deploy to it, and if you don't use it after 10 seconds, it basically goes down. It's not like a AWS Azure that you need to rent a machine and you need to go stop it and stop. Modal is like quickly. As soon as you stop working with it, it goes down. So if you work with the platforms like that, they are pretty easy. All you need to do is that you basically specify which model version you want, and you have a Python code, and it starts a machine and that's done. The problem with that platform is that, well, they are expensive because they do the engineering for you. You don't technically do it, so they charge you more. But if you want to deploy it yourself, and now you want to reduce the cost, and you don't want to use a platform like that, let's say you're going to use Azure or AWS and stuff like that. Now, you need to have an ops engineer that understands cloud services, how to basically deploy, basically your team, your Python team, basically engineering team builds a deployable package that contains the model, basically, right? Or you read from Hugging Face at the same time. But you need to be sure that you have there that is stable, accounts for any scale up, scale down, depending on the request that comes through, So there are lots of engineering techniques you need to do to have a production level deployment. A simple deployment as a research, as I told you in Model, If you read it, it's literally less than 2 lines. You can switch, deploy, and you will have a node that's running and based on GPU that you use, and you have an API, you invoke it. For research level, pretty straightforward. But when it comes to production, because you cannot use services like that, because services like that, after you don't use it, it goes down. You want a stable rented machine, and you need to account for it that this GPU that I rented, if it crashes, what happens? So I need to basically, you need to always account for this stuff, right? So there are more engineering cost and basically time that you need to put to deploy a basic open source model yourself. But if you have that knowledge, your team is capable of doing it, probably is much better to just get one of these Hugging Faces. Like there's so many good models these days, and if you're comfortable with doing it, you know the process, it's probably better to do open source. All right. This basically answered this basically chapter. All right. So the other thing is, okay, you need to also cost out the whole project. Again, LLM project, basically the costing is basically different. It's not like the general ML projects. You need to account for basically all the costs that comes around LLM. And this says the LLM is not just the cost of the membership. It's you're actually technically you get paid per token. You have limits, and the cost comes on the tokens, right? So you need to account for that. Does it make sense for you to charge your customer with respect to that, right? Because if you think about it, you can build a product with a certain LLM. Are you going to give a free access to your customer? That means they can make as many as possible queries, or you're going to create a tier and you say that you only with this tier you only get 500 queries. With this tier you get 10,000 queries. With this license you get 10 users. So you need to come up with all of this, and you need to, in order for you to do that, you need to account for the overall cost in the worst case scenario of the LLM deployment. All right, so let's take a pause here. Right.
So.
Why rules of machine learning?
Right.
Google uses machine learning in many different ways in many different products. We've probably.
Okay, guys. Let's listen to Google. So the link to this is on the canvas. I highly recommend you to go through this post, but let's just watch this 8 minutes of this.
We made every mistake at least once by writing down rules of machine. Why rules of machine learning? Google uses machine learning in many different ways in many different products. We've probably made every mistake at least once. By writing down rules of machine learning, we can learn from each other's mistakes. The guiding principle of these rules is that the key to building a great machine learning system is to be a great engineer. In other words, write simple code, make it readable, and comment it, test it, fix the ever-present sign mistake, leverage peer review, version control, track performance online, and finally, launch and iterate, launching something great and useful, but expecting to make it even better when you see how people use it. Now, there are a lot of rules I've written down, and today I'll give you a selection of some of my favorites. Rule number 1, don't be afraid to launch a product without machine learning. People think of a machine learning system as something that magically makes decisions. In practice, these decisions are the outcome of considering historical data and objectives. For instance, if you have some retrieval system, you can first rank documents by recency, and then gather data about what you've done in the past and how users responded. Now you can learn. But you needed some kind of product or prototype to gather that data. Rule number 2, make metric design and implementation a priority. At a high level, it is the overall health of your product that matters. Are users engaged? There are many ways to try to get an idea of this. Are they spending time? or clicking more, or directly indicating their happiness with +1s or comments or reshares. These metrics are like your pulse, blood pressure, or cholesterol level. They don't guarantee that you are in good shape, but changes of them could be a good or bad sign. Moreover, having the best pulse or blood pressure in itself doesn't indicate you are in great shape, and it is in general hard to come up with a single number that represents your well-being. Thus, don't worry about which one is the right metric for your product. Track a wide variety of metrics in order to get a feel as to how they interoperate. Rule number 3, choose machine learning over a complex heuristic. If you were trying to rank videos, you could imagine ordering them by the number of watches. However, you could also imagine ranking them by the number of stars. Or you could blend these two approaches. At some point in time, it becomes unclear what you are trying to accomplish. If what you really want is for people to click on the videos you show them, then you can build a model that predicts the probability that they will click on a video and shows people the videos they are most likely to click on. You can use your heuristic and the inputs to your heuristic as features to build a model, but your model is guided by your objective. There's an analogy between a machine learning algorithm and a compiler. A compiler takes a program in a high-level language like C++ or Swift and compiles it into an executable. The compiler can take into consideration the machine that the program is going to run on, say a Windows, Linux, or Mac machine, and then creates an executable for that. If there is a new machine, you create a new executable. Likewise, machine learning takes data and objectives and creates policies. This brings us to what I call the fundamental law of machine learning. Anytime we need a policy, we can either write it directly, a heuristic, or come up with an objective and use machine learning. At a large enough scale, what you want the system to accomplish is easier and more efficient to express formally than how you want the system to accomplish it. So early on, before we have data, we are going to use heuristics. But as we get more data, more computational resources, and more engineering resources, machine learning becomes a clear winner. Rule number 4, keep the first model simple and get the infrastructure right. When people think about machine learning for the first time, they think about learning, those few lines of code that take the data you have gathered and produce the model that you want to serve. However, a more accurate representation of what a machine learning system looks like is this. Most of the code and time creating a pipeline is in gathering the data and then applying the model that was learned. The reason for a simple model first is that often an incredibly basic model will get a lift. Keeping it simple with a few features means that any issues or irregularities are easily attributable, and that makes it easier to test the infrastructure and the data. Once a simple pipeline is in place, a more complex one can be added later. This is an example where the perfect is the enemy of the good. Get a model out in a quarter or two gets a team hooked on machine learning. Rule number 9, detect problems before exporting models. Okay, is there anyone here who likes getting bad news at 2 a.m.? Anyone? No? Then rule number 9 is for you. If you are updating models continuously and there is a problem in your learning system, this problem can reach the users. The last chance to find any of these issues is during exporting models to production. Why should you care? Well, if there's a problem during learning, you can send the engineer on call an email. If there's a problem with an exported model, your on-call is getting a page. The solution is to have basic sanity checks on the model during export. Specifically, you should be checking both the size of the model, so it doesn't crash servers, as well as the performance of the model. If you know that the models that are exported are solid, then depending on your product, you only have to worry if a day or two passes without exporting a model. More generally, what you want is a boundary between your genius and your livelihood. Regardless of how a model is created, you want safeguards in place to make sure that the model is good enough for your users by comparing it to your current model, using it internally in your company, called dogfooding, and running experiments. Rule number 12, don't overthink which objective you choose to directly optimize first. Imagine that you are not sure whether time spent or clicks is a relevant metric for your product. You start by optimizing clicks because it is a directly attributable metric. You notice that when you optimize clicks, time spent also goes up. This is a common occurrence. The first model often improves metrics that are not directly optimized. If you find that all your metrics are increasing, then you can stay with a simple objective. Of course, this too shall pass, and we'll talk later about how to recognize when the time comes to modify the objective. Rule number 13. Choose a simple, observable, and attributable metric for your first objective. Why simple? Because often heuristics are so bad that choosing any decent metric as an objective will get a lift in all metrics. Why observable? Because defining something like user happiness is hard and will take a long time. Also, if you are predicting something that can be observed later, then debugging will be easier. Why attributable? Attribution of some long-term objective is very hard in practice. Don't go there. So long as improving directly attributable objectives is improving your long-term metrics. Rule 29. Log features at serving time. If you are lucky enough to be able to log each example as your model makes a judgment, do so. There are various tricks where you log pieces of information that could theoretically be put together to reconstruct the example that your model saw, but they are incredibly hard to make work correctly and nearly impossible to test. If you really need to worry about space on disk, then be creative with how you compress your logs after the fact. Rule 38. Don't waste time on new features if unaligned objectives have become the issue. Imagine you are going through the launch and iterate cycle, but launches aren't happening. Specifically, you add features and the offline objectives improve, but the side-by-sides are not good in the eyes of the team. Or you add features and the online objectives improve, but the online metrics go down. In this scenario, you want to tune your objectives to better match your medium-term and long-term goals. Rule 39. Launch decisions are a proxy for long-term goals. A machine learning expert wants an objective to optimize. They expect that increasing that objective will lead to a launch. However, it is not always that simple. While there are many short-term metrics that can be used as an objective, which metrics are most correlated with medium-term metrics like downloads per day, time spent per day, clicks per day, in other words, metrics you can measure in a live experiment, is unclear. It is also not easy to use these medium-term metrics as objectives directly. Predicting click-through rate is not the same as maximizing clicks per day. Then there are long-term objectives, such as satisfying users, increasing users, satisfying partners, and profit. Finally, there is your true goal, a useful, high-quality product and a thriving company. In my personal opinion, the future of machine learning is not about more and more complex models for predicting clicks, but about figuring out how humans and machines can work together to determine how to best reach our long-term.
Yeah, so definitely listen to them. They have done enough mistakes. So take a look at that post. You will find it interesting. Some of the decisions that you might want to take, they already have posted there. So might not do that. All right, let's continue and then we can take a break after that. All right, so now in general, you can ask these questions when you're going through your scoping that, is it going to be build versus buy? That means something we're going to build ourselves. We're going to go through some cost buy. It's going to open source or proprietary models. First party data or third party data. First party data is always cheaper because it's the data that you already have. Third party data means you buy it, but basically the recommendation is that buy third party data for that portion of your data set that's incomplete. So use whatever you have, and the portion that you don't have, just buy the data for that. And compute requirement, basically, you just account for GPUs that you need. And remember, not always you can access GPUs that easily, but the cost also, remember, for your project. All right, so the next thing is that, defining success, and that's going to be pretty important for you At the end of the day, whatever you build, you need to have some definition of this is a successful build. This is something that we're proud of. It is we build it. It's not just a piece of code that it runs. So you need to basically, in order to define success, you need to be more than engineers in reality. You need to think of you need to think like a business person, but also you need to understand the human basically interaction with your tool. Whatever you build is going to be used by some humans, right? So you need to understand that, okay, who are this user? Who am I selling this? That's actually, I always ask during the demo, I ask teams, okay, who should I be? You're trying to demo this product to me. Who should I be? Am I a student? Am I a banker that's coming to you? Am I like finance person? So you need to first figure out, you're building a product, who are you building for? Who's that you are targeting? Who's your audience? Okay. What are their values? Which problem should we solve for them? Let's say you're trying to build something for finance. And you're like, okay, I'm going to target for VC basically ventures or VC basically offices. And then in VCs, there are so many things you can solve. Which one should we basically pick for those? Which one should we solve? How will you solve it? How do you know when you are done? So these are type of questions that you need to ask. It's kind of like a human-centered AI. And there are more questions like which user problems are AI system uniquely positioned for them. But all of these questions help you to basically shape the core value of your product. Whatever you build, you need to have basically a core value for it. And these types of questions will help you to do that. Then you basically could also ask questions about user experience, basically, how can we ensure the helpful experience, basically, how we define success for a user, if the total time they spend on the product or basically the interaction, thumbs up, thumbs down, you basically need to define certain things like that. Again, at the end of the day, you need to identify user needs and AI strength, because it's so easy to use AI to build things, but it's if it's actually a valuable product is something that user will like it's not going to be that easy. So you need to also remember one thing. Whenever you try to come up with an idea, there are technically at least for our AI domain, there are two questions that you can keep in mind. Is this like a people first approach, or is it going to be like an AI first approach? People first approach, the question that you are going to ask is going to be with respect to the user. Who's the real user? What's the pain point? What can I solve for them to help them? That's the people first approach. So you figure out the user audience that you have, you want to help them, you want to build something for them. In technology first approach, you basically start with an already existing technology and say, I'm going to improve that, I'm going to make it better, right? Like someone else already has a company or a product, and you're like, I like that product, but I think I can improve this part of this product. I'm going to build something similar, but with certain modifications, right? So that becomes kind of like a technology first approach. Both of them are also valid. It just depends on the idea that you have, what you're building for. The other question that you need to ask is that does AI basically add a unique value? Is it necessary to use AI here? Basically, does it need AI? Could I just simply use a heuristic approach for it? Maybe I don't even need AI to do that. Could I do a simple, regression problem instead of going through all this basic model trainings? Then the next question is what's at stake? What's at stake is kind of like it doesn't apply maybe that much to what you do in the class, but that means what is the cost of error? If we make a mistake, and our customer basically they get a wrong answer, what will be the cost of that error? Is it going to be an acceptable error, or is it's going to be a problem, right? So that's really important, and that's something that you need to gauge at the beginning of scoping. The company knows, like my previous company, we were cybersecurity. If you think about the first cybersecurity, you cannot basically have an attack that you miss it, right? So you need to basically detect all that attack, but it's okay if you stop someone and you assume it was an attack, but it was not an attack. The false positive is okay. false negative is null, right? But then also false positive, you basically need to gauge this. Okay, I know false positive is okay, but how much false positive is okay? Because if you haven't, let's say you have a cybersecurity app and then you're constantly alerting, like you have a lots of false positive, what will happen? Users silent, right? Because you kind of become the boy who cried wolf, right? They don't believe you after a while. They're like, okay, this app doesn't work. So you want to be sure that you balance, you figure out for your product which one is more important. You basically find a balance between those. And then the other thing is the user context. You need to also understand that who is working with your product, and consider that people are different. People are coming from different culture, different backgrounds. They basically will experience your product different, right? So you need to account for that. So it's not going to everyone. You're not going to react the same to what you are building, right? So that's a reality about that. Again, when it comes to basically AI costs, also as much as you can try to reduce using LLMs, probably, because the cost of the compute power that goes through. If it's a simple task, maybe you can just simply using a simple model that doesn't need a GPU, versus if it's a more difficult task, then you need to use LLM to do that. But as much as possible, probably break it down. Lots of companies, they do that. If you go on Google, for example, search, and before Google try to use any LLM and stuff like that, they do lots of smaller search, that doesn't require any GPUs, basically. And if necessary, then they basically invoke a large model to answer you. All right. Let's do a pause here. Let's take 10 minutes. We have about 25 pages to go. Then we will have labs. So today all right. So as part of the scoping, one of the things that's really important for you is that be sure that you understand the nature of the problem. Be sure everyone in your team knows what you are solving and what's the definition of that problem. So you need to clearly define the problem that you are trying to solve. Validate your framing with some users. If you have an idea, like let's say you are targeting, okay, we are going to previous semester, a team basically was building an app for finding roommates in Northeastern. They were saying that currently lots of time we are using WhatsApp for finding roommates, and it's not easy on WhatsApp. There are links, and you need to basically click on this link and you go through so on. And the idea was that we're going to basically solidify that anything that's being posted on WhatsApp channel and connect it to this our platform, so students basically can go on our platform to find roommates and stuff like that at Northeastern. And in order to do that, basically, they sat with some of other students that they are not part of the team, that they are using that Slack channel to try to understand how they approach it, what's the pain point that they have, what could be done better, and what will cost for you to come use my platform instead of just going back on the WhatsApp and sending basically right again. Right. So you want to also do something like that. Be sure that whatever idea of framing that you have, you can validate it with some real users. It doesn't need to be so many users. Even one or two users gives you some perspective. Okay, and just be sure to don't pick your friends. They could just simply say yes because they're your friends, right? So then interview with some extreme users. There was some extreme users basically that could change things differently. But remember that if you at any point in your career build a startup or you work in a startup as a founding member, you will see that lots of time when you get the early adapters, that means early customers, you need to kind of do whatever they're asking basically. And those early customers, they request a lot. You're like, okay, we're using the platform. Can you add this? Can you do this? Can you do that? Right, so on. And those kind of early adapters becomes your your early, like extreme users in a different sense. That means they are the only one who's using your app. They're going to ask a lot of questions to solve the problem for them, but that doesn't mean the problem that you're solving for them, it will be actually beneficial for you, right? So when you have customers who work with someone that's like as part of early adapter, if they have a request, doesn't necessarily mean that you need to say yes to all those answers. You can always collect the data in a proper way, basically respond that, okay, we will work on it and so on, we will add it to the queue, and then work on whatever comes as a commonality or like more important. For unknowns, consider basically how the problem might evolve also with having AI in the loop. Then remember to have diverse, some sort of like a diversity in the, or diverse basically views in your process. Especially these days, it's really important to understand that we will talk about bias and fairness later, but having diversity helps you to see a different view, see a different perspective, not just maybe if you're like a 4 male engineer sitting building an app that they're, maybe it's better for you to, ask someone else, maybe a female that joins, that helps you with certain basically part of the product, because you might not just have that view yourself, right? So that be sure that you diversify your team. It's kind of like it's not that possible always, but just keep that in mind. Also remember that a system perspective, perspective is always also matter. Do you one of this company, I forgot the name, I always forget the name. What's the name of that company that they have a really good agent? Not Cloud, Anthropic. Yeah, they had this interesting talk, the CEO of Anthropic, and they were like asking about question like they were talking about how they are making the models better and better. Basically, they were like, one of the things that we care a lot about is the context. And what was the context here? It was that if we ask a question from our model and we look at the answer and the model doesn't understand it or the answer is bad, before we just drop that question or try to update it, we actually look at the context that we pass to the model to answer that question. And we pick the same context, like a prompt and the data, the exact same way that we pass it to the LLM, and we pass it to some engineer, someone, and say that answer the question. And we pass that to multiple people. And basically, they were focusing on like why the context matters for the AIs, that you need to be sure that despite the fact that these models are basically strong, but you need to also account for that what these receive, it need to be actually proper. Like it's like if we just pass a bad data, but the large amount of data, and cannot expect them to solve it. So account for that. Now, let's assume that you have a user and you're building this app, that this user wants to use your app, and the idea of the app is that user takes a photo of plants and they want for the app to tell if this plant is toxic for the cat or not, right? So the first thing, if you as someone engineers who are building this, the first question is that, okay, there are multiple plants in the picture. When user takes a photo, which one is the one that I need to focus on? So in the first thing, as part of your process, AI basically pipeline, is that you need to do object detection. That means you need to be able to detect multiple plants, separate them from each other. Right? So you need an object detection step, some sort of like an image segmentation. And after that, basically, you need to do some sort of like here in this example, we use a regression, but you need to have some sort of model that decide which one is probably the priority, which one is like maybe more in the focus, like which one might be the one that user wants me to answer me based on the way that they took the photo, right? The front, maybe the image in the front, or the plants in the front. Then basically you need to do a search. So the third task is to do a search now online about this specific plants and gather some information, right? And the next is that basically you gather that information and you do another maybe regression here just hypothetical. And then you come up with basically a score and say that, yeah, good, this is bad for your cat. This is the toxicity level based on the data that we collected. But what it means is that a simple task that user come and they just took a photo, and as an underlying basically process, you actually went through maybe 4 models, to just answer the one question, right? Because this is assuming that you are not using VLMs, LLMs, stuff like that they have all the domain knowledge basically, right? They're just building a simple app that has 4 maybe a smaller model that can run on a cell phone, Now, well, these days you can. Any one of you have worked with Nano, the Gemma Nano? Nano Banana? No, Gemma Nano Banana is for the image generation. There's a Gemma Nano, yeah, the SLM. This is really good for vision tasks. So they released it recently, and there's a video if you go find it. Someone basically, it was a competition, I think, and someone won the competition, and the person who built the best product was this gentleman that is I think his brother has like it's kind of like a blindish. There's a youngest brother, and then he used that basically Gemma model, built this app that as basically kind of like connected to a cell phone or Raspberry Pi, I don't know exactly. But as it goes, it basically describes what's in front of you. So like because like let's say they go outside and there's something he can't see, the AI constantly describe there's for example, car in front of you. This car is in this color and things like that. So simply with that one app, basically one model as a small model, it could basically build an app like that, and that helps a lot of similar publicity, right? So that was just this document probably you need to build 4 models to do that. But if you use a model like that, small language models or a small basically vision language models, they could probably do this in one process, one pass. So then the next thing is that you also need to always understand how do people frame this problem. It's kind of like a deterministic answer. It's like an open-end basically type of basic question. And how people actually frame this problem. How do they solve this problem? Those are types of things that you need to understand if you're building something for your user. That's when user try to solve this problem themselves. Do they have a definite answer, like a yes or no type of thing, or no, they're just like an open-ended basically question. The other thing is that you all have heard of alignment probably. But so user goes through similar process called specification, and a specification basically it's as the same as an alignment that we have heard before, is that to ensure that your model or pipeline AI aligns with the intent that the user had. So whatever was intended of the user, you need to basically be sure that there is some alignment basically over there. And misalignment actually has its downside, which could be poor performance, computational safety, reward hacking. Those all could come from the misalignment. This is similar to the alignment that we do for LLM training, but not exactly the same thing. So when it comes to framing, keep 4 things in mind. First is the primary goal. What does the user want to do with this tool that I'm building? Like that's the primary goal, what they're trying to solve. There are some sub goals. In order to solve that, what are the additional things that I need to solve in order to reach to the intent that the user? So in the example, that user wanted to take a photo of the plants and ask us if it's a poison or not. In order to achieve that answer, we need to accomplish 4 additional steps. Right? Those are the sub goals that you need to achieve in order to reach to the final answer. Under specification, what assumptions that basically knowledge is left out? How would it cover it? The assumption could be in the example that we had. We assume that maybe the plant in the front has a higher priority in compared to the plant in the back, right? That could be one thing. Optimization basically can you optimize one sub goal and that impact the other one? That means if I improve one of those models, will it change the other one? Or something like that. Especially anytime if you deal with hierarchical pipelines, that you have a pipeline that one is a model, generates an answer, that answer goes to another pipeline, another model, and so on. One of the questions is always that if I change the model at really top, do I need to change the rest of these models? Right? Because that model, if it changes, the output that it generates kind of change. Now, does that impact the rest of the pipeline? Right? So this is something that you need to keep in mind. Okay, so you need to also account for bias and fairness. Also remember that bias technically could be subtle, systematic, and deeply contextual. We'll talk about bias more in details, but even if you are using API calls, your product, you can still account for bias and fairness in your final product. Okay, so just because you make an API call to another model doesn't mean that you are free of bias. Okay, because you didn't build the model doesn't mean that you are free of bias. So you need to account for that anyway. Now, when it comes to design, remember to have diverse basically perspective for your design. Is every team here has someone with a front end experience? Like every one of you has someone in your team that has a front end experience? No, yet? Kinda? All right. I can see some over here. Yeah, so as I said in the previous class, just when it comes to your design, try to be early. Don't wait through the end, just start early, come up with some design ideas. Like even on a whiteboard, how do you want the final page to look like or final app to look like? You can just plot it or draw it on a whiteboard, take a picture, pass it to Gemini or ChatGPT. They will convert it for you to an app or to basically UI. So, but design it yourself just on a whiteboard. Like, how do you want this to look like? All right. But when it comes to generative AI, also on the other end, you need to remember that the results are unpredictable, right? So in classical ML, answers are basically deterministic. Like if you predict yes, it's always basically predict yes for this answer, the data, because the weights are fixed, right? And the generative models, no, it's going to be different. So every time you ask a question, you technically get a different answer. The context might be the same. The wordings are going to be different. If it's image, the image doesn't necessarily look the same, right? There will be differences in the pixels. So you need to account for those changes, but then also you need to be sure that there are certain protected characteristics. Basically, you need to account for those and be sure that the generative model does not basically have bias toward those. And this could be age, disability, education, geographies, cultures, physical attributes. Those are type of things that you need to account for. Okay, you know the protected characteristics, right? Like you are technically by law you are not allowed to use this in any model training. All right, in reality, that means that if you have an app and your app rejects someone, like for example, age. If you reject someone based on age, like Asia's protected characteristics, well, you get sued, right? If you reject someone based on the gender, sort of bias toward that, you get sued, right? So those are like a protected characteristics. You need to account for this. That means in model training, those features, you are not basically going to use those, right? If you need to use gender, like I said, it's a medical domain, and you need to use gender and age. That's different. It's not about decision making. It's about proving the health and stuff like that. But if you're denying service to somebody, your app denies service to somebody, or doesn't approve them based on the particular characteristics, you are at loss. Okay, just keep that in mind. All right. So You need to always have some guiding questions. So for your scoping document, we also will give you, actually for scoping data and model, we will give you a worksheet. So you will, for every submission, you will have one worksheet that you need to submit on top of the documents or the GitHub or the video, whatever you are submitting. That worksheet basically, you just submit one person from the team, not everyone. You just, but it's going to answer a series of questions that shows that you went through that thought process and you and your team basically discussed these types of things. Okay, so you will first get one for scoping, you get one for data, and you get one for model. Right, it will be posted later. But there are a series of questions basically that you need to understand how people think about this problem, how do they experience the problem, basically how do they frame this problem also. Is there any similar or different, basically, this problem similar or different across different dimensions or identities? Just ask questions, just keep in mind and remember. Now, when it comes to models, there are three main models that you're going to work with. Traditional ML models, generative AI models, and rule-based models. Right? We're not going to go over this, but the idea, classical ML is for any of the following tasks, you can use classical MLs. When it comes to generative or LLM, could be any time that you want to help with user fatigue or basically reduce the repetitive task or task with the difficult jargons and stuff like that. You want to improve the efficiencies, things like that. You can use basically this generative LLM types of model. And then you could also just simply use rule-based systems. And those are when the maintain predictability or when the decision is really crucial. You cannot use ML predictive models. You cannot use LLMs. And you want to be sure to use a model that is really precise and you can interpret it. Then you use rule-based models.
In a couple of slides previous where you had the guiding questions thing.
This one?
Yeah. What's the difference between how do people think and how do they experience? Like, because to me they're very closely related. So like how do they do that?
Right. So that's correct. It's really related. But let's say, let's pick one example. Let's say when you come take this class at MLOPs, what do you think about like, am I going to learn from this class? Right. So you have some idea, but versus when you come sit in the class, what do you experience from there? Right? So how you think about something versus how you experience it are technically not the same thing. Like even if it comes about a problem, let's say you think about you having a problem, but until you experience it, like it happens, you actually don't know how I'm going to experience it, right? So it's always different, right? So maybe there is a problem that you want to solve, but how that problem being perceived, it's good for you to also understand. Yeah. So, when it comes to generative AI, just remember that these types of model basically are different. Why? Because they are kind of like open end. They generate text, image, media. It's kind of like this. Classical models, they just make a prediction, regression, classification, recommendation. They basically interact via natural language, not with a fixed input text. Up to this point, if you build anything on classical ML, your input is always fixed. Like if you have 4 dimension as an input to the model, you always get 4th dimension and you pass it. You always ensure that it goes through a series of processing. When you build a product with LLMs or VLMs, stuff like that, on the other end, user can pass a text. Text could be one word. They could just write one word. It could be a full sentence, paragraph. They could paste it, full document over it, right? So from one perspective, it's easier maybe because you just get free text as an input. But from the other perspective, if you think about it, you need to be able to digest large amount of text maybe, or sometimes they upload a document and you need to be able to still process it and pass it to your model and generate the answers, right? So you need to account for those types of changes. Might make your data pipeline easier, but then also there are other challenges. keep that in mind. So, for now, for your workflow, again, try to first understand the current process. One thing that every semester we have asked every team is as part of your scoping, you need to submit one document. So if you are building something new, like you're building an idea which is new for your product, you need to basically create a flowchart, kind of like this flowchart. And this flowchart goes through a process of a simple flowchart that says user comes here. It's like a user enters from here, data, passes the data goes through this, and this is what we predict. The steps that happens within doesn't need to be precise. It could be a mapping what you think you're going to do, right? And it will basically change it. If this is going to be a new idea. If you're working on an existing idea and you're like, there is a product, I'm going to improve it. One thing you need to submit is that, this is like existing. You need to submit current approach. That means do a search and build a flowchart of what do you think is currently being done in the industry, right? And then you basically put an arrow here and says that we're going to fix this part of the chart. So you need to submit something like that shows that you understand the current approach, how it's being done currently in the market or by others, and which part you're going to focus on. All right. So I recommend you don't say that we're going to fix everything. Right? Just pick something that you know you can prove that it's basically broken or I can improve it, and just it's something that's also measurable. That means you can come back and say that we did it. This is the basically metrics that we use, and this is how we complete the comparison. So, understand the current process, investigate the adjacent products, how basically other users basically working with how other companies have built it, prototype and validate early. Try to do as soon as possible, try to validate your idea. Let's give you one example. If I give you a data set and says that, can you use ML? Can you use an ML to solve this data set? Right? What's the quickest way for you to tell me if it's feasible or not? I give you a data set with labels, right? And I ask you that basically, is this feasible or not? I'm not telling you solve it. I'm telling you, is it feasible or not? What would be the quickest way for you to do that?
Size of the data set?
No, not necessarily. Right? The data could be large, could be small. Pick one model and overfit it to the data. You guys know what's overfitting? Why do you think overfitting will tell you about feasibility?
Consistent.
If I bring the data and I bring a model and overfit it to that, what does overfitting means for that model? What does memorizing means with respect to feasibility? The model can learn the patterns in this data by memorizing, right? If you bring a training data, force it to the model to basically overfit to it, and test it again on it. If the model makes mistake on the same training data, that means it might not be feasible. It's difficult for AI, even by overfitting, to answer the same question. Right? So the fastest way you can do is just pick a portion of the data, overfit to it. If it's feasible, then you can say that, okay, yeah, I think we can work on this. If not, then you're like, okay, we need to look further. So prototype and validate early. There are some platforms that you can use also for basically assumption check, like Wizard of Oz or Google AI Studio can help you with those. So map existing workflows, what we just talked about. Best practices, find similarity and variation other tests. It's kind of like comes similar thing, but if you break down your task into multiple tasks, you can also understand that some commonality across the tasks that you're solving with other ones, and that could also bring some adjacent product for you to work on, right? So it can also help you to detect the feasibilities and rate. This is the same thing that we talked about, critical moment of failure. Oh, yeah, this one, maybe critical moments and failure. Just be sure that you understand certain things, like how things could break. That's a really important question. One of the questions that you need to always ask yourself is that, what could go wrong, right? When it comes to building a product, what could go wrong? What will happen if that went wrong? How could we survive it? If it break, if this happened, what will happen? How could we come back? Right? Those are the types of things to keep in mind. Right? It's like especially if you work on a startup, you always need to have a plan B if something went wrong, right? To account for it. Another example is that if you think about your company, all of a sudden you were part of the breach and you lost customers' data, can you come back from that? Right? It's like lots of time companies can't come back. They get sued, and after that they have lost everything. So you need to be sure that if you work with these types of customers, like is failure acceptable or not? So otherwise, you might lose everything. All right. So 1 second. All right. So GitHub Action is one of the best tools in the market for CI/CD, right? So it was actually funny. I don't know if you saw that. There's a post on on X or somewhere. Someone says that it's time for a new platform to come and replace GitHub for CI/CD. And the GitHub official account responded that let me know if that platform's code is on GitHub. So it's kind of like the reality about GitHub is that it's pretty standard and accepted at this point. I personally really like it. I don't think it should be really something really valuable, like some rewarding platform, but to change to go to a different basic platform, like something should be really big, like such a reward. But we're going to use GitHub, and most of the companies also will use GitHub. So what we want to talk about is the concept of CI/CD. Now, in order to talk about the CI/CD, we also want to, because lots of you going to do API calls and LLMs. And this question was previous semester also. Well, I don't know what's the CI/CD for me. I don't have a data pipeline, and I just have an API call and stuff like that. But you need to think about this. So you have your GitHub, which is technically your code repo, right? And you and your team building some product. And this product has series of components. One part of this is that API call, right? So you start with, let's say you have a data ingestion. Then you have, I don't know, like if you need to do, let's say sometimes some of the APIs you need to apply prompt templates, right? So basically you have some processing, even if it's small. Then you have, let's say, a small ML code for the API call. And then you have a UI that technically sits above all of this. User interacts with on that UI, UX, and then you have this cloud, like this is GCP, for example, and connected to the UI, UX, right? So you and your team writing code, right? So this is your code, right? And multiple of you, basically, one person working on this one, on this one, on this one. And you basically use this repo pushing the code over there, correct? And the last thing you want is to push a code, like one of you push a code and breaks it for the rest of it. Because something here changed and this one didn't expect. Or something here changed and this one didn't expect. Right? How could you evaluate and avoid problems like that? But that's basically where CI/CD comes into play, right? So the idea will be that you want to, whenever you push code to GitHub, you don't want to worry about any of those problems. You want to have a pipeline that, or a workflow, the correct definition is that. So you're going to have this workflow that runs as soon as code comes through, and whenever this, as soon as code comes through, now we're going to talk about that. There are different ways that the workflow could run. One of them is that whenever the code wants to go to a merge to main basically branch. But that code basically will run a CI and then we'll run a CD. And we will later have CT and CN. Okay. CI basically is going to be a bunch of code that you're going to write, and anyone that is adding, we're going to add to that CI. And it's going to do a series of tests, like a unit test and stuff that you need to do, validation tests and stuff that you want to be sure whenever a new code, new modification came in, that runs to ensure all of this will work. Nothing is broken. The code is valid from unit tests and stuff also. So that would be your CI. When the CI is done, depending on what you want to do with this entire package. So the code that you write for you, at the end, you need to convert it into some sort of like an image. Because you want to deploy it, right? How are you going to deploy it? Most of the time, you're going to use some cloud services. So that cloud services, in order to deploy, the best approach is to work with containerized apps, right? Containerized app means that to convert this into a Docker image, right? So as part of the CI will create an image for you. That image will go to your continuous basically delivery. CD will be responsible to do a final check. That image that we receive, is it working fine? Right, so it does some check on that image. If the image is working fine, it is connected to your GitHub, to your Google Cloud, and it will write that image in the place that's called artifact registry. So this is your code registry. It's going to be artifact registry. Technically, some platforms, they separate artifact registry from model registry. So that means if you have a model training, you write the result of that into a place called model registry, that you version the models. But some, like GCP, combines all of this, consolidate all of that into a place called artifact registry. And artifact registry, when you build a bucket in it, technically, you could be a basically Docker file, could be a model file, and stuff like that. So you, based on that, the definition will vary. But your CD will basically write to Google Cloud, which is here. Then, and so as we go through this class, you're going to see this. When there is a new file to your artifact registry, that means there's a new package, and you want to serve that package to the customer, you will have some sort of like either listener or kind of like a trigger. Listener and trigger are either pull or push. Push is a trigger. That means whenever there is an artifact registry, you trigger something else because you want to serve it. So you send a push request to another service that is responsible to deploying that new package that you have. That service could be, I don't know, you're running it on Cloud Run, you're running it on Kubernetes, you're running it on Cloud Compute, depending on where you're deploying. We will get to that later. Or it could be a listener. And listener basically means that the same services that you have, they also have an option to listen. Basically, they have basically they're always monitoring this. And whenever there's an activity, there is a new file added here, this new version. They will pull that new version themselves and basically load, right? So by doing so, you basically will create a pipeline that code goes here, You don't need to worry for the CI/CD is automated. CI/CD will generate the artifact goes here. Another one is listening or pulling, and this pipeline can continue by itself, right? The devil is in the details. It's not that easy. There's so many steps in it, but that's the process. So the first step for all of you is this CI/CD part to ensure that you can build this workflow that can run by itself. So it eliminates the need of manual check, manual verification, and stuff like that. Okay. Is that clear so far? All right. So for that, we're going to work with GitHub Action. So GitHub Action, basically, it's kind of like it's a workflow, right? And this workflow basically defines whatever need to run in your system, right? And as part of the workflow, these GitHub Actions are a YAML file. Okay, it's a YAML file that you're going to create. This YAML file going to have certain characteristics. One is that an event is like the occasion that this workflow need to run. What will trigger this workflow? What was that event? Event could be a push to the pushing a new code to the repo, could be an event. Creating a PR, merging into a main could be an event. Manual trigger could be an event. Cron-based time, like a time-based, basically, could be an event. Right? So there's all like different ways that you can trigger basically this. And then you have runner. Runner basically is that CI/CD will need to run series of codes for it. So GitHub by itself, there's not an operating system to be able to run code. So in order to run code, what do you need? You need a VM. Or you need a virtual machine that can run the code. So that's technically your runner. So you're going to basically tell to GitHub workflow, I need, for example, Ubuntu version 22, right? In order, as my virtual machine, in order to run the rest of the coding. So you first get your runner, the virtual machine that you want to run, and then within that, you're going to define jobs. And jobs are going to be steps that you're going to go through, like, I want to first do this, do that, do that, do that, so on. So you define. Part of your job could be, let's say job one, we're going to see through the code, is install Python dependency. Want to do that. Then maybe the next step is that I want to run a unit test. So you basically have a code to run the unit test that you already have developed. The Python code is somewhere else, right? We're going to see that. So that is going to be the runner will have a job, jobs will have steps. So let's start with workflow. It's a YAML file. We're going to see how to create that. Then events is going to be what will cause this workflow to trigger. Okay, push, pull, like sending a post, like an API request. Jobs is going to be set of steps that you want to go through. That becomes a job. And action basically is kind of like a specific task within your workflow. So all of this, and again, we talked about runner is just that machine that's free to run this. So now let's see how does this work. The first thing is that whenever you build a GitHub repo, by default is the Git action is not activated, or it's not by default, you don't have. So you need to create a folder, and the first folder you see .github, and add it to your repo. Right, that's where basically the workflow will be there. So this folder here, .github, you basically create that, and within that, you see I have this workflows, and within workflow you will have these YAML files. Any workflow that you define, which is correctly defined, and you put it here, it will automatically, GitHub will automatically detect it. And when GitHub automatically detect it, you can see those workflows as part of action. So here on top, you see action. So if you go to actions now, these are on the left, these are the workflows that are available that GitHub detects from that folder. Right? And we're going to talk about how they would trigger and stuff like that. But this page that you see shows the workflow. For example, this one was trained done. Green means it was done. Right? And every workflow, when it's done and run, if there was an error, you will see a red. Somewhere here we have lots of red. Yeah. If the workflow basically wasn't successful, you will get an error like that. You can also have a way to receiving a message like a Slack email about a workflow that wasn't successful. Right? Any questions so far? All right. So now let's go to labs. So we'll go to GitHub Labs and lab 1. So the idea of this lab, so most of the codes that you will see in the repos, they're like a standard, just simple classification regression codes, right? So I'm not going to spend time on the model and the data. It's just a simple example picked from scikit-learn probably, right? So it's kind of like this. Yes.
For ML models, training and compute power is very high. So how does support on GitHub? Like, in case we using GitHub Action instead of the VM, will the VM not be lightweight machine rather than?
Yeah, you can force up to certain, basically, if your model is not a really large model, you can train it on. Lab 2 that we're going to do now, we're actually going to train a model using GitHub Action. If you're using a larger model, I think GitHub also offers compute engine. Yeah, larger ones. GitHub Teams and Enterprise, basically. You can get the GPUs. Right? But
We request that or like we connected with our cloud provider.
so for your task, because you don't have GitHub Enterprise, right? GitHub Teams or Enterprise, you cannot request those. So that's not option available to you. So for you, if your model run is small, you will see you can use Git Action. Otherwise, you just connect it to your GCP, and GitHub will be connected as part of the process will send a request to the GCP. The new code here, grab the new code, use the new code, train a model. Right? That will be the pipeline. So here, this SRC code. This is just 4 functions for a calculator. Okay. So one function does x plus y, the other one does x minus y. So it's kind of like a simple calculator option. So that's within the SRC folder. We have this data folder. There's nothing in it. Test. We have 2 tests: PyTest and unit test. These are just to show you. Okay. So if you have a code, if you want to do a PyTest, you can basically write a test like this. And the idea will be like, let's say, so here we are building a calculator, right? Doesn't matter how fancy that calculator becomes in the future. There are 4 main functionality that they need to work, right? So it doesn't matter what's the brand of calculator, 4 plus 4 always should be 8, correct? So when you write these tests, you're expecting a deterministic answer for operation. Doesn't matter what will happen later in this code. All right, so you will basically write series of operations and you say that these are the answer that I expect to see. Right? And this is kind of like a PyTest. This is similarities. You can do a unit test, and unit test basically is kind of like this. You build a class and then wrap it in the unit test, basically. Right? Same idea. Okay, so now we have 2 test files, a PyTest and a unit test. Okay. Now, what we want to do is that we want to build a workflow. And we want this workflow to be like, anytime there's a new code, I want that workflow to run the unit test and the PyTest, basically. Okay, so anytime there's a new code comes to the GitHub, like to your repo, you want the CI to run that unit test and type test. And if it's successful, to basically create a basically alert, or if it wasn't successful, to create an alert. So this workflow, so I have these two files here, but I have the copy of the same files in the .github/workflow also. Because otherwise your GitHub won't detect it here. I'm in the nested folders. So let's go here. All right, so how does this YAML file can you all see the screen? Yeah. Okay. Do you want me to turn off this slide, or it's good? Good. Okay. Enough. Yeah. All right. Sorry, it made it dark back then. Let's see. No. All right. Let's continue this way. It's a movie theater now. So your basically workflow always starts with a name. We always need to define what's this workflow name, because that name is going to show on your Git action list. Okay, so here we say testing with PyTest. And you also give the run name, it's going to be PyTest. And then you see where they're on. On is that definition of that event trigger, basically. What do you want? Like, what will be the scenario? What will cause this workflow to run, to trigger? So we're going to say it's going to run on push. Anytime there is a push to the repo. So you can change push to pull. Right? We can push, pull. When there is a push, the first question is that, okay, push to where? Why that's important? Because think about it. If in your team, there are 5 engineers, right? As a practice, when you write code, you never directly push your code to a main branch, right? Each one of you will have your internal branch list. So there are technically, let's say, 5 branches, 1 branch per engineer, and there is some sort of like a dev branch that you consolidate the code there, and then you send it to the main branch. So what you don't want is that to trigger the event anytime code comes to like a user internal branch, like engineers branch, because those are not important. You only want this to trigger if the code comes to main branch. All right. So that becomes that's how you separate the branches. Like you want to specify a specific branch to trigger the event. After that, there's a release. Okay. So you can basically kind of like a filter out, because you could also push code to a main branch, but is not a release code. Like, so you can basically have them, like define filters on what should cause this. There are much more that you can do, but this is just a gesture, okay, for the push. Then you can say branches ignore. Which branches ignore? Don't listen to. Like here, for example, I said dev branch, don't listen to the dev, right? Like you could have basically say that I want, like instead of push to which branch, we should just say ignore one branch, like it includes every other branch. So this becomes a push event. Now, the next thing is that you're going to define a label for it, for example. Not necessary. These are all just for practice for you to see this. Okay. So for example, you can create a label and say the types of it's going to be created. That means the push created. Issue, if you want to open and basically open issues or label issues if you want. But you don't need necessarily label and issues, but you can basically add those. Then the next thing comes. So up to this point, you just triggered something. Now you have jobs. Now jobs basically tells you that, okay, now this workflow trigger, what is going to happen? Jobs are going to be all those steps that you're going to go through. So you're going to say here, the job is to build. And that build is a name that you give over there. It could be just CI, for example. But this job is a build. And in order to run this job, you need to first tell GitHub, I need a virtual machine. What do you need to run this on? It will run on a machine with Ubuntu latest. Okay, so you can have a different versions, right? There are all sorts of basically operating system that you can basically find. So if you go on GitHub Actions, search for runs on, you can get list of all possible operating system or machines that you can run on. I always use basically Ubuntu latest. And then, so that separates the machine that is going to run the code. Then, the next thing is that checkout. What is checkout? So the idea is this: you got a VM. You don't have access to it. Checkout means to enter to this VM. So you always need that checkout code because that's when you shift to run inside here. Okay, so there's going to be checkout. So step one is going to be a checkout, and you give it a name, checkout code, for example. And then it says it uses. So what does that mean? In order to go from here to here, you need to write some code in order for GitHub to do that. Luckily, you don't need to do that. It's already pre-written. So GitHub comes with predefined actions that you can use, right? Some actions you need to write yourself, but there are some actions that are predefined because everyone using it, so they've already predefined them. So here, basically, it's a user's action backslash. That's actions goes to the. So if also you search on GitHub list of all possible actions, you can see all the predefined actions. And you want to use checkout @ version 2. Actually, right now I think it's on version 4. So I think this code is pretty old. So that it does all this process for you. You don't need to write any code for this task. It's going to use action checkout version 2 or version 4 or version 3. Okay, next step is that now you are in this VM. Basically, what would you do generally? I would first install the dependencies, right? Or basically install Python, you know? So step one, because that's like a blank machine, you're going to set up Python. Because set up Python is also something that everyone does. It's already an action file for it, like action basically definition for it. Action set up Python version 2. And with is ask you which version of Python do you want, for example. Say Python version 3.11, 3.13, whatever. Right? And this is not just Python, all languages basically exist there. Then what will be the next step? Now you have Python. Install all the pip dependencies that you need in order to run your code, right? So that's what you do on your own computer. If you want to run something, you install Python, then you install the pip dependencies. So you basically do install dependencies, pip install -r requirement.txt. Here, the assumption is that in the main folder, there is this requirement.txt file. Okay, so that file should exist. That's the assumption. Okay. So, step one, next step. So I wanted to run the test, basically, the PyTest, and generate a result, basically write the result to a file. So I want to run test and generate XML report. How do you run a PyTest? You just run PyTest. If you have already Python and you haven't installed the dependency, you just need on your terminal to write PyTest. And that's assuming you have a folder called test, and within that you have a file that imports on the top the term PyTest. If you don't have that, it doesn't detect PyTest. So PyTest, and then that's unit XML. Basically, you will see that I'm going to write the result of the PyTest to this file. Continue on error false. So that basically means that I'm doing a test. What will happen if one of these tests broke, like a fail? Should I continue or should I stop? Sometimes you might have flexibility or like, okay, continue because I want to maybe out of 10 tests, if 7 passes, you're good. But sometimes you're like, no, I need to stop. This is a calculator. 2 plus 2 cannot be 3. So I don't continue on the error, basically. Right? Okay. So the next thing is that upload the test results. So yeah, a couple of things to keep in mind is that whatever happens in this VM will be lost after this process is done. Right? So if you generate a file here, if you don't upload it somewhere else, after you are done, you don't have access to it. So basically what we do here is that upload the test result. If we always upload the test result. If it failed or if it basically passed, doesn't matter. And for uploading, GitHub already has also an action, upload artifacts version 2 or version 3 or version 4. Which file, test result, what's the pass? That's the pass to the file basically. So you are telling to this that there is a file in this VM generated above. I want to upload it to my GitHub. That means to my GitHub. So this is your GitHub. There's a VM in it. You bring the file out. So later, when this is terminated, you have access to that artifact. Okay. Does that make sense? All right. So, and then notify on success. Basically, you say if success, basically print that echo test passed successfully. Notify failure. If failure, echo test failed. All right. So this becomes a simple, kind of like a CI without packaging part. But it just basically runs a series of tests and let user know if it failed or if it passed. You can do the same thing exactly for the unit test. So everything else is the same. You just unit test. You just run it as Python minus m unit test. Okay, so it just doesn't matter unit test or Python. And you can put this all together in one Git action. Okay, you don't need to separate those functions. So now what we can do. So because I'm not logging here, but I'm going to push something to the repo, and we will see that those basically, because it's on push to main, that those should basically trigger by themselves. So yeah, it's heavy as well. That I think so. Okay, so I'm going to push now. And basically, we'll just refresh this. So you see those workflows triggered. This workflow is for page deployment. That's not related to like we have a page built over this ML repo. But so you see this one, the second one, testing GitHub Lab Python unit test and testing GitHub Lab Python PyTest. Okay. So we look at the unit test, right? So let's understand. So remember in unit test, there were a series of steps that we went through. So if I go here, this code that's running, I finished already, but if you go to build, those are the whatever you define in the workflow. So starting with setup job, checkout code, remember, and then set up Python, install dependencies, run PyTest, notify on success, notify on failures, post setup Python, which just kind of comes for the cleaning, goes out by default, post checkout, complete job. And you can click on those. So for example, if you go up, okay. Well, I cannot click on it because I'm not the owner of, like, I'm not logged in. But you can click on it and it basically shows you the, let me see if I can try with this. All right, so if I go action here, um, and fill. So here, if I go to here, that was the wrong one to click on. Run unit test. Basically, it shows everything that runs, and if you have more steps in your code, it actually will show all the steps that you go through. On top of that, workflow file, basically it shows you the file that you have, usage. Let's see an artifact. Let's see. We should have one artifact file. Okay, okay. So one of the tests had artifact. Remember, it was the uploading the artifact back. So if you want to access that artifact, you when you come back to this page, you see here it says artifacts 1. So if you click on that, test result, a zip file, basically the result that whatever was written to that artifacts. And over time, I think if it's, I think this is multiple runs, but that's how you can get the artifacts back. It will basically write it for you and you can basically access that. All right. So let's go back to this. All right, now let's take this one level further. What if we want to use GitHub to train a model for us? Like a GitHub action to run a model. Yes.
What if we have a custom package that we have created and we want to import it into our file?
You have a custom package that you created and you want to import it to your final. What can you?
Final model Python code. Basically, we want to have a final main and we are creating a custom package for it, which has some custom functions that we are defining. We are trying to import it within our main.service. So when we run the GitHub actions, how does the
Let me see if I understood correctly. So you are saying that as part of your GitHub action, you want to import some codes that are custom.
No, as part of my main.py,
Yeah.
main model
Yeah.
import, I want to create a custom package.
Okay.
And I'm using it within my main.class, within my model code.
Okay.
So how does the GitHub action know that hey, I have to pick this package up and run it as well? How do we run the test on this?
So you define the code. We're going to see an example. So as part of the steps, so in the previous example, I use everything as a predefined GitHub action tasks. Right now, in this example, we are going to write the steps as a Python code space. Okay, just bear with me. If it didn't answer your question, then continue. So let's say, let's go to GitHub action. So let's say you have this idea that you basically want to, you have this code, train model, which what it does, basically gets, it's not just random code, okay? So uses scikit-learn to just train a classification model, all right? And so in order to do that, we basically, I'm going to use that. Very much. Okay. So, so this is the idea for this lab. The idea is that whenever we run the train file, this basically need to train a model, and this model need to be saved. Okay. And then there is a next step to evaluate that need to read that saved model, test it, right? What does that mean? Think about it. You have a pipeline and you generate ML models. So the model could be good, but should you use it or not? There's always some additional tests that you do. What are those tests? You compare this model with the previous model. One example. Is it better than the previous one? Yes. Next question. Is this faster than the previous one? Is this within the boundaries? So there are a series of tests that you do around the model itself to evaluate. So you run this evaluation, and then you write a result. And then you could have additional check that if the result is approved, we go to CD. Otherwise, we don't do anything. Right? So as part of this, the idea was that every time model comes, I wanted this model to be timestamped. That means that I know when exactly this model was trained. Timestamp it with time. The challenge for that was during the training, the timestamp is different compared to this because this is a sequential process. So whatever was timestamp here, I don't know it here. These are like a separate steps. So what I did as a hack was, as soon as the Git action starts, I get a current timestamp and I pass it along. I have a fixed timestamp at the beginning of the process, use that through the end of the process. So it's a timestamp when the process started, not when I was here, basically. So in order to do that, you see there's this one line timestamp argument. So this, as an arg, this code receives an input. So there's an input to this trainer timestamp. It's just a one input value. It uses that, basically first creates a data for the classification randomly from scikit-learn. Then it checks to see if this data folder exists. So what I need to do is that I generate a random data. That means every time there's a call, I get a random data. I need to split the data into train and test. I need to write it to a folder so I can use them later or compare them. So there's data folder basically. Then you don't need to know about MLflow, but we will see in the upcoming classes. MLflow is a platform for experiment tracking. Basically helps you to gather all the information around the model run and data processes so you can visualize them later. We will see that later. But so we look at the current timestamp, and I will create an experiment ID using the timestamp that we have. That part is not important. We will see MLflow later. And then I build a random forest classifier and version that model and dump that random forest classifier with the file. So simply, to simplify it, generate a random data, split it, generate a random classifier, save it. And then you need to go to a text. Okay. The next step is this evaluate, which basically as an input gets the same timestamp, because based on that, we know which model file should we pick. So it picks the same timestamp, goes, finds the model version, loads the model, generates some new data to test this, kind of like a last attempt to test the data, to test the model again against some new data, and create a metric and save the metric in a folder. So I'm going to also have another folder called metrics that I basically save the model, metrics there. So two random file. This is a Jupyter, that's not important. And okay, so we have this test, there's nothing in it. Then models, basically every time we develop a model, automatically, one model was trained 10 minutes ago, and that's when I ran the previous code. And then every time there's a model, there will be also equivalent metric for that model, basically. So how could we create a workflow for this? So we go to, so there are two workflows. Technically, they are the same thing. One of them is on push. One of them is triggered manual. So you can also have either cron job, like a time-based, or you can have a workflow to be triggered by force, like a manual trigger, right? So let's go on push. All right. So as always, this always start the same. On top, you give it a name. You define what should cause the trigger on push, which branch, main. Okay. Then what are the jobs? So you give it a name. It's going to be a retrain job. And that job, retrain, is going to have a series of steps. So always first start with a job. Job is a fixed term. What comes after job is a name that you define. That doesn't matter what. So here I say train, retrain. But what comes after that are going to be the steps within that retrain job. Okay, so steps, we're going to have a fixed term steps. You start with the same thing. You're first going to ask for a VM. It's running on basically Ubuntu latest. Then you check out in that VM. Right? And here I use version 4. Then you set up Python. You define a Python version. You install the dependency. Here I specifically use the path to where is this requirement file exists on your basically GitHub. Then remember, in order to train a model, I first need a timestamp. So I create a timestamp. This is like a bash code, right? You basically create a timestamp. I save that timestamp also in a text file, but also write it in an environmental variable. So I can reuse it. So this is this line. Basically, create a timestamp, save it to a file, write it to a variable. Then in line 30, check file permissions. Sometimes you do, like a GitHub doesn't has permission to run, execute the file. So I check for the file permission, give it a basically permission to execute. Not always will happen, but for this example was happening. So that line 31 and line 35 is just a step to go through to give permission to GitHub to execute that code, basically. Then line 37 is this, to execute train.py. On line 37, it's a Python file. So how do you run it? You use a command called run. Run, what does it mean? Python, and you pass to this file. This file as an input needs the timestamp. So you pass the timestamp to it as an input. As a result, that will save a model with that timestamp. Then I want to run this evaluate function. So you go to evaluate, I'm going to run that, give it a timestamp to it. Within this, there is a code that will go find the model with that timestamp and evaluate that model. And it will basically write that metric file. Remember that as a result gives me this metrics. So this metric file, I would check to see if this basically folder exists. If the folder exists or not, obviously created. Remember, whatever happens here, basically stays here. So you need to later bring it up. But first thing I do is just this is not the best practice. It's just to show you what are possible to do. I'm using a move command because it's just a Linux to move this file to this folder. Okay, so I'm just using a move command to move the file to a certain folder that I'm expecting. Then store and version the model. Same thing, I basically come up with a version for the model. This is something that you can do as part of your CI/CD. You version your model in your Git actions based on some definitions that you have. And then I move the model also to a folder. Then the last thing is that commit and push changes. So what is happening here? So I don't want just to get an artifact out. What I want to do is that whatever happened in this VM, because it's actually, so what happened was that I run a train, I got a model, and I got a metric file. But I built two folders, and I moved this model and moved this file into those folders. Those folders technically exist in this VM, but on a copy of my MLOps repo. So I have a copy of MLOps repo here. That copy has two additional folders that the general MLOps repo doesn't have. The model folder and the metric folder. Did you get what I'm saying? So think of this. This is the MLOps repo. This is the repo, right? There is a version of this repo within this VM. At the time of creation, this VM is identical, correct? But after I ran some code in this VM, this repo has two additional folders, which the original repo doesn't have. So what I want to do is that I want to add that, commit that changes to the original repo. So the original repo comes to the same structure that the new changes has. So in order to do that, you can basically within this VM, you authenticate yourself with the Gmail, with the GitHub, and you add whatever file that you want to add, you commit those files, and you push those changes to your repo. So as the result, this repo will also be updated. Right, so if you have your code, your pipeline is somehow that some changes happen and you want this change to automatically impact the repo, not maybe the main branch, maybe some other branches, then you basically do something like that. So all of this is basically a Git command to push the new changes to the repo. Now, one thing is important is that how would you, because if you think about it, if you want to push to your GitHub, you need to authenticate yourself. So the problem is that this machine is not authenticated with GitHub. How would you authenticate this? And that GitHub has made that pretty easy. So you can, on the bottom here, you see environment. You will define an environment, and you can over there have your secret variables. So instead of you try and manually authenticate this machine, you give this machine permission to read GitHub token. Okay, there's a secret file GitHub token. That means this machine doesn't need your permission. It's automatically authenticate itself with GitHub using the current scope, which is you here on this machine, to authenticate itself. But where does this GitHub token exist? So anytime you you have your project basically on your GitHub. So here there's a setting. So you go to the setting, and within the setting here under security, you see here it says secrets and variables. So if you go to secret and variables, we have action, code space, dependency. All right, so let's go to actions. So you have secrets and you have variables. So what you can do is that, you see I already have this are predefined. So let's say, do you know what's the environmental variable when you work with your Python, right? So you can do the same. Imagine your code needs environmental variables, or your code needs secret variables, and you don't want it to be part of your code base so someone can see it. So the same way that you define it for your machine, for your code to read environmental variable, you do the same thing, but you put your environmental variables or secrets as part of variables and secret in your GitHub. So all you need to do is that, basically, let's say it's a secret, you say, I want to add a new secret. You give that secret a name, and the value goes here, and you say add secret. After you do that, or you put it under variable. After you do that, so if I go back to here, all you need to do is pass the address to it. It's a secret dot whatever was the name you chose for it. So that automatically GitHub knows that, okay, in order to do this authentication, I need to do that. So we will see it in the next one now. We want to connect to GCP now. So you want to connect to GCP, connect your GitHub to GCP to push a file, store it in your artifact registry. So you need to go through lots of process of confirming with GCP that I'm an authenticated user. So how would you do that? So you basically create a secret file, put it in your GitHub secrets, and as part of your Git action during that process, you authenticate with GCP by sharing that, kind of like a handshake. And then you can basically send the file to the artifact registry. Yes.
Is the secrets variable is that something that could import specifically, or is that specific to the functions?
So
it's already a known variable in the GitHub action.
It's known variables if you use it in this form, basically. Or you basically say secret dot if within the GitHub action form,
Right.
like environment, not
I
in
don't
your.
have to define.
No. All right. So let's. Any question on that? All right. So. I know you all want to leave, right? We do one more, like 5 more minutes, and then you all set. So now we want to connect this to your GCP. Okay. So all right. Okay, so let's continue. Let's. All right. Let's wrap it up, then we can go. All right, so how many of you have worked with any cloud services before? All right, perfect. To make it easier. So GCP, all you need to do is that basically, for those of you that you haven't worked also, it's pretty straightforward to learn. It's a platform that works in a certain way. So you need to have an account, which I recommend you. So we're going to give you a credit. You need to register only with your Northeastern account. Don't use your Gmail, because as soon as you try it, that credit is gone. So it's not, there's no way like undo the task. So be sure it's only your Northeastern account, okay? But anyway, so you basically have an account. You start by building a project. So you always need a project for the tasks that you do. So for this task, I already have Git action GCP project, which I'm going to use, okay? So for this lab and all other labs, as we know, there is a full videos already recorded on the repo that you can watch in details, okay? So I will speed up through them, but you can watch the full detailed videos. So for this lab, what we want to do is to do 2 things. So the Git action part is the same thing. We're going to have the GitHub workflow, but what we want to do is that we want to connect our GitHub to GCP, and we want to on GCP to create a bucket, kind of like a data warehouse, like a place that you can dump unstructured and structured data. So bucket is like a really cheap place for the storage. We will talk about that later. But in order to do that, you go here on the left tab, and as you go down, You want to see this as a storage? Oh, here, cloud storage. And you go to bucket. Basically, you need to do create. You give it a name and you just simply say continue and create. When you do that, just a name and hit create. It basically creates these buckets for you. So when you click on your bucket that you created, there's a configuration. If you go to that configuration, this is the address to your bucket. So that means anytime from any machine, if you are authenticated to GCP, if you have validated yourself identity, you can use that bucket address to send data and pick data from GCP. So you need to just create a bucket and pick that address of your bucket. Okay, so that's one step. So you need a bucket. The next step is that, well, how do you identify yourself to GCP? How do you authenticate yourself? So in order to do that, there are a couple of versions. We're going to do the old school first. We're going to create a service account. Okay. Service account is going to be a JSON file that you create on GCP within the project. It changes if across projects. So within a project, you're going to create a service account, and then you either put it in your GitHub as a secret, or you put it on your local machine to authenticate yourself to GCP. So in order to do that, go here, go to I am an admin, and you go here to service account. Here, service accounts. You basically say create a service account. You give it a name, and that's create and continue. Let's just give the name. Random. Create and continue. And then this part, permissions. So by default, when you build service accounts, they have almost no permissions. And you need to, one at a time, to define those. Why is that the case? Because in a company, if you give a service account to one engineers, you don't want them to control everything. You always give a limited, and actually as an ops person, your responsibility is to control those, to give limited permission based on the scope of the project and what you think they should access. So you basically limit that process. So here, so you select a role and you define based on what you think they're going to access. For this project, these are also already documented before, so you don't need to write down. But for this project, basically, so this Git actions, if I go to permissions, we have given the following permission to artifact registry administrator, the storage object admin, storage admin, and the owner. So that means this service key will be able to read and write to a storage object, to bucket. But it's also able to interact with artifact registry, a place that you can write your Docker model basically within this project. So you define the roles that you want this to have. So and after that, all you need to do is that when you have the service account, you come here on the action, manage keys, and you add a key. As soon as you create a key, each one of these are a key. It will download a JSON file to your machine. You have that JSON file, you open the JSON file, copy the context of that JSON file, you go back to your Git action. You go to your settings, to the secrets, create a secret for that for GCP connection, paste whatever you copied from that JSON file, and save it. Now you have that file, that secret file, on your Git action, but it's not connected to any project. Okay, does that make sense? Yes. So now, if we look at how that project will work, so if we go here, So this train and save a model, basically, what we want this to do is it basically again random code to generate a random forest classifier, but we want this as a result to write the data, write the I think the model and the result to a bucket on GCP, the same bucket that we just saw. So in order to do that, you need to install Google Cloud basically library. And from google.cloud import storage. The storage is how you can connect to this. So there's a function to download data, to pre-process the data, to train a model, and returns the model as an output. Then save model to GCS. So in order to do that, this is how you work with the Google bucket. The storage was the code that you imported, .client, you created a client. Then you, for that client, you pass the bucket name, the name that we picked from there, and bucket.blob, basically, so everything we write as a blob into this bucket. For read and write, basically use this blob term. Now, depending on what you are trying to transfer, text or bytes, read and write is kind of a little different. But here, because we're dumping a model, I'm going to use IO like a input-output bytes IO. This is like a for model transfer. If it's a text, is easier. We just write a text. But this will basically help me to send a binary file technically to the bucket. You need to use IO basically here. So this job-lib done, this model done. And then you say blob, I want to upload from a file. This is the model. This is the buffer, sorry, and this is the content. And it just say that I basically model was successfully uploaded. So as a result, this model won't be on my GitHub stored. It will be stored in my bucket in my GCS. Okay. So basically, it helps you to save a model. This part, save a model that trained on your Git action into your GCS bucket. So. All right, there's nothing else on that. So if I just simply run that, so the action file for here, the action file for this is going to be just a little difference, but on the schedule is a cron job. Every day at midnight it will run, but also workflow dispatch. Workflow dispatch allows you to manually trigger workflows. The jobs that we have, we get Ubuntu latest, same thing, checkout, set up Python, install basically. So it's just a clear some cache or pip to avoid reinstalling basically. That is the step. We don't need that. Get cache dependencies, install Python here. So up to this point, we just installed something and used cache to avoid some installation. Authenticate with GCP. Because this is also a process that a lot of time happens, GitHub already has that action file for you. So Google GitHub action authenticate version 2. So you just need to basically run that. And it will ask you, in order to authenticate, what should I use? And you say to authenticate with, this is the credential file that I downloaded from GitHub, and it's stored in this address. So it uses that to authenticate itself, and then you run this Python code. So if I just trigger that here now, so. All right, so I just triggered that, and if I go to actions, train save model, There's going to basically run all of this. As a result, we should see one model file will be stored in the bucket after this is basically done. All right. While this is running, let me run the attendance. All right, be sure that you have your access, whatever you need to do. It is what?